But I talked about those tensions. You have to look at population now in the context of the requirements for food and the ability of the system to produce food. The upper curve you can see follows the population. That represents the requirement for the output of agriculture. The lower curve represents the amount of food that could be produced given the resources that we devoted to it. And we can look a little bit and see what those resources were. One of the parameters, well, here's food consumption per capita. So basically it's held relatively constant, a little bit of an increase. But here's a major factor. In this model, there are three classes of land. High yield or highly productive land, which is the lower of the downward sloping curves. So there's land loss over time. The second land quality is the top one that's also downward sloping. And there's some transfer of low quality land from the forestry sector into agriculture over time, and so there's a little bit of low quality land. This is obviously a limiting factor. The amount of output that can be grown is the amount of land times the yields. And you can see historically yields have gone up quite sharply, the black lines. But in the future, for a variety of reasons, agricultural yields in a business as usual scenario turn over and tail off because of agricultural practice and a number of other factors. Soil quality loss. The other factor that drove the increases in agricultural yields was the increase in the intensity of the use of fertilizers. The black curve that's upward sloping represents, in a way, the green revolution that both mechanized agriculture and applied large quantities of fertilizer, and fertilizer is really energy. The other interesting component of this is the diminished productivity, if you like, of the transformation of crops, what comes out of agriculture into food. And what this really represents is an increase in the intensity of meat in the diet. And this leads to the observation that as there's more meat in the diet, there are more cattle, and cattle is a very inefficient machine for transforming animal protein into meat and dairy products. And so the more meat we eat, the less effective, if you like, is agriculture. I've added on here the green scenario. And so what I've done now is say, take the reduced population and look at the tension between the availability of food and requirements for it. And you can see that this food shortage now is much less, but the onset is not much different in time of global food shortage. But we have to see population and food in the context of energy. In this business as usual scenario, the requirements for energy that's driven by increased standard of living, which is the top red line, is much greater than the availability of energy. And in our business as usual sort of scenario, we've tried to stay with a fossil fuel world. Of course, what you're seeing in the lower curve is the peak oil phenomena, that the production of fossil fuels will peak and turn over. And this was as seen from about 1993. The other piece of context that is important has to do with forestry. So this represents the total requirements for forest products. And you can see in here in about 2040 or so on, the forest really collapses. Now I think we've shrunk geography down. There's no geographical distributions on anything. And what this really represents historically is that we have been harvesting from old growth primary forest, and when that's gone, all you get is the marginal productivity, which is very low, and you see this collapse. And the green scenario does little to affect energy or the timing of the collapse in forestry. Out of this mess of data are a couple of lessons learned, conclusions that we drew quite some time ago. The first one is the dynamics of population reduction is really out of sync with the time horizon for the onset of food shortages. We can't imagine getting the population lower any more rapidly than that green scenario, and that's not really imaginable either. This really agrees with Susan's conclusion that population by itself is not the answer. Reducing the scale is ultimately helpful, but working with the population variable is not going to resolve any of the crises that are in front of us, either the energy crisis the food shortage crisis or the collapse of forestry. Those are quite, in a way, independent of what we can do about population. The second conclusion is do not use land-based biomass from forests or agriculture to produce energy. That is just biting into the capacity to feed people. It is almost unconscionable that we divert the resources that could be used to feed people into feeding SUVs. Ironically, the only step that Ottawa has taken in response to the climate change crisis is to put $2 or $3 billion into the production of ethanol from corn and from grain. And that has been the only response. There's a lot of talk about doing things beyond that. We hear talk about carbon taxes and so on, but we're miles from getting them, even if they were effective, which I doubt very much. The third point I've already made is that this crisis in food has to be resolved in the context of these other issues. And so that the notion of using even more fertilizer or mechanized agriculture, which was a bad idea in the first place, is now not possible. Overall, one large thing stands out is that there is an urgent need for a rapid transition to a low carbon or a zero carbon economy. Now, as this issue is being driven by climate change, and we're now being told by science that the acceptable concentrations of CO2 in the atmosphere are not the 450 parts per million that were talked about a few months ago. They're 350 parts per million. And when we realize that we're now at 387 parts per million, we on this planet have to get to zero carbon and become carbon positive within the next 50 years to keep the temperature rise within a 2-degree increase. And even so, there's only a 50% possibility that would be effective in keeping this situation as dire. One of the experiments we did was to see the only effective way of increasing the food supply in the short term is to shift to a more vegetarian diet and to do it very quickly. And I'll close with this. Here is the simulation experiment where I reduced the concentration of meat in the diet back to it was in about 1950. And you can see the blue line represents that difference. That action, in a sense by itself, would begin to resolve the food shortage problem. There are many other interventions, and I guess one of the lessons you learn out of this is that there are no single interventions in these kinds of systems. You have to intervene with many variables at the same time, and the timing and intensity with which you apply those variables is extraordinarily important. And I don't think we're into this kind of mindset at all. We're reductionist in our approach. We have a problem here and we try and fix it like that, and another one over here and we try and do that, not realizing that these problems are tightly connected. With that, I'll close. Thank you very much.
Robert Hoffman co-founded What If Technologies in 1989. As president, he has management responsibilities for corporate finance, business development, and research and development activities. For clients, he is responsible for project management, workshop facilitation, and model design. He began his career in socioeconomic analysis and modeling at Statistics Canada. There, he held a number of research and management positions, including Director of the Structural Analysis Division, Director of the Science and Technology Statistics Division, and Associate Director General of Analytic Studies. He was appointed Research Associate Professor in the Faculty of Environmental Studies at the University of Waterloo. There, he was Senior Project Manager at the Waterloo Simulation Research Facility. Robert holds the degrees of BA and MA in Economics from the University of Western Ontario and is the author of several published works on socioeconomic modeling. He has extensive knowledge of data sources, surveys, and data collection methodology. He has extensive experience in modeling quantitative techniques and in research management.